When we are looking at simple linear regression, what we're doing is starting with some independent or predictor variable and some dependent variable and seeing if we can fit a line between the points. This is the standard equation for a line. So y are the result, the value of our dependent variable is equal to alpha, that's the intercept, plus beta, that's the slope, times the value of our independent variable. So this is our linear regression line, that's the equation, and the things that we're going to focus on are how well does this line fit the data that we saw, and how steep is this line? What's the value of beta? Some of the assumptions that need to be true before you can use simple linear regression. So we can only do this if you've got one predictor variable, one variable that you think you can use to predict the value of some outcome variable, which is, again, not the same thing as cause. It's just that if you know this predictor value, how well can you guess what the outcome variable would be? We're assuming there's some sort of linear relationship or a good reason to think there's a linear relationship between these two. Both x and y have to be ratio or interval data, and the outcome variable also needs to be continuous. And we expect all of these data points to be independent. So if we have 30 data points, that means that we expect they came from 30 different people. We're not getting 30 data points, 15 of them before some intervention and 15 after. It's 30 data points from different people at one point in time. The coefficient of determination, r squared, is what tells us how accurately we can predict the outcome from the predictor variable. And if r squared is 0, then there's just no relationship. And you would expect that the average value is going to be your best guess of what the value for outcome for any particular predictor value is. If r squared is exactly 1, that means that if you know what the value of the predictor variable is, you can tell exactly what the value of the outcome variable is. What's usually the case is that r squared is somewhere between 0 and 1. And the bigger r squared is, the more accurate your predictions are. Beta is the slope. And unfortunately, beta shows up in more than one place in statistics. So you may have seen beta described as power, the probability of a type 2 error. This is not that beta. The beta we're talking about is the slope of the regression line. So the steeper your line, the bigger your beta is. R squared is always between 0 and 1. Beta can be any value. And what you're looking for when you do a linear regression is some sort of strong r squared. So if you remember correlation, we said a good correlation was an r greater than 0.5. So an r squared greater than 0.25 is also a strong relationship. Statistically significant. So this p-value is telling you what's the probability that you saw the data you saw if the slope beta is actually 0. And then the final thing you want is a steep slope, and units matter. So if you're interested in the amount of time spent practicing handwriting on handwriting quality, because maybe you want to make a case that the students in the classroom you're working with should spend more time on handwriting, practice, it matters a lot if your slope is in terms of seconds or hours or days, right? If your slope is in terms of seconds, then a slope of 10 means that every 10 seconds you're seeing some improvement in the slope. If your units, some improvement in handwriting quality. If your units are days and your slope is 10, that means it takes 10 days to get 1 unit increase in handwriting quality. That's a big, big difference, right? So what you want to see is a steep slope so that a 1 unit change in the input variable, the predictor variable, leads to a big change in the outcome variable. And we've talked a little bit about the difference between statistical significance and clinical significance. So this is what we're talking about when we say we're looking for a clinically significant result. So you want to see a big R squared so that the association is strong, and you want to see a steep slope in your regression line so that a small change here gives you a big change here.